Okay, welcome again. Not again, yeah. Welcome to my class today. And the title of this class is Signal and System. Uh, Allow me to describe about this class. And sorry. And this class has a credit for 3 SKS, yeah. And this class will be held regularly in Friday and in Friday 1 p.m. around 2.5 hours. And prerequisite of this class is engineering mathematics. And for the lecturer is me. And let's move forward to the learning outcome. This is important for us as well, for me also, to let you know that for this course has been assigned for two LO, learning outcome. First is number 8 and number 6. The definition of number 8 is the student is able to apply knowledge of mathematics, physics, ICT, and engineering to solve a complex problem in electrical engineering. And the first LO number 6, student is able to solve a complex problem in electrical engineering with methods, skill, and modern IT device. And this learning outcome then are breakdown into course learning outcome. Course learning outcome means that once you pass this course, you have to be able to demonstrate characteristic of linear time invariant system and signal manipulations. And also, you also have to be able to analyze discrete and continuous LTE system in electrical engineering applications using signal transformations and convolution techniques. And the two, these two CLO then are breakdown into several sub CLO. In this case, we have 7 CLO. First, student able to explain definition of signal and system, and then able to categorize type of signal and system with their example in real words. Able to explain the LTE system in time domain as well as in frequency domain. Able to apply signal transformations in Laplace domain. Able to apply signal transformation in Z domain. And the last is able to analyze digital filter using the software. Yes. And this course cover material. Actually, this is more clear in the content of this course. First is about the definition of signal and system and type of signal, including continuous, discrete, elementary signal, deterministic, and random signal. And then also type of system and their characteristic, and the LTE system in time domain as well as frequency domain, and then Laplace Z transform, and then uh, designing a filter, digital filter, uh, either using FERR or WIR, double double IR, based on the MATLAB, yeah. But if you want to use another software, also permissible. Uh, the reference, yeah. The reference, you can refer to the book from Simon Hykin and Barry Van Veen, about the signal and system, published by John and William Sons. And second is Dennis Freeman lecturer notes from MIT, and then you can access from this website. And also for the MATLAB, yeah, particularly if you want to use a MATLAB, you can use the book from pengolahan signal digital with dengan pemrograman MATLAB, written by Professor Dadang and Pak Filbert. And then the also important evaluation for this class is first is individual assignment, which is 5%, and then for the individual assignment to 5%, and then for the group assignment as a project. So in the end of this class, before we have a final examination, I will give you for creating or for designing a filter, digital filter using MATLAB, which has weight being 30%. It's quite high, so please uh, be concerned about this. And then we have a quiz after mid examinations. This weight has a 10%, and for the mid examinations is 25%, and for the final is 25%. Okay, and as long as we have online course, and as long as we don't have a regulation or recommendation from the rector uh, to conduct offline class, so we will use this Zoom link for every day. Okay. Uh, this is topic distributions, but it's still written in Bahasa. So distributed into 16 weeks. This is first week. We will discuss about this sub GLO or CPMK. The indicator is student able to explain definition, signal, and system. Next week, second week, and third week, fourth week, 5 until the final 16 weeks. So at the end of December, yeah, at the end of December, we expect that this class will be finished. So anybody already enroll, yeah, to the IMAS? And please, if you don't, please enroll yourself to IMAS. And I will let you know the, how to say, wait moment, for the enrollment, yeah, enrollment key. For the enrollment key, enrollment key I'm writing on the WhatsApp for the mass as well. Okay. 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 And then let's move forward to this. My dashboard, and then open the signal system, and then okay, that's all. And is there any questions? If no question, please access your AMAS. There is a pre-test, actually not for grading. Actually, that's for checking what your initial understanding about several terms. So please open your AMAS, yeah. Open your AMAS and please conduct the pre-test, yeah, at 30 August and 5 September. Yeah, right now you can see, yeah, this is a pre-test, yeah, pre-test. Please open yourself and then please fill your name and then try to answer the following questions. You have maybe 10 minutes for submitting the answer. The following is not signal. Body temperature, body temperature, blood blood pressure, thermometer, eye blink. The not signal is thermometer. Yeah, the not signal is thermometer. Okay, okay. Hmm, the following signal is thermometer. The correct one is uh, maybe 10 student. Okay, please try again. Maybe you have any questions about why the note signal is thermometer? Thermometer is device. Body temperature is signal. Uh, since the okay, later I will explain. The following is a system. A system. Okay. System. The correct is smartphone. Yeah, the correct one. The correct answer is smartphone. Okay, maybe I will explain from the number one. The following is not signal. Okay, let's check together. Body temperature. The body temperature usually tells us some information. Yeah, body temperature usually tell us some informations. For example, if our body temperature is uh 30 30 around 36, yeah, around 36 means that our body is in a good conditions, right? And slightly higher if we have maybe 37 or 38, our body feels not, yeah, not better lah ya, not good gitu ya. Maybe feels how to say, fever, or even we have a 40 degrees Celsius. It's mean that our body is really in risky conditions. Maybe we should call a doctor to check what happened with our body. Also, if our body temperature is maybe below the 36, is kind of hypothermia, yeah, hypothermia, when our body temperature is below the 36, and it's gonna be also risky related our healthy, because our health, because yeah, the such this body temperature, what we can conclude, the our body temperature tells us the condition of our body. Yes. So it's kind of a signal. Yeah. Bringing information from our body. So that's the maybe the doctor or healthy health worker can determine the condition our body. Yes. Also for the blood pressure, blood pressure, the usual blood pressure, means that we are in normal conditions, is around maybe 120, yeah, 120 per 80 maybe, yeah, 120 per 80. And then if the blood pressure is higher, tell us, yeah, or has a meaning that uh, our body also is not the good conditions. So it's kind of signal as well. Okay, the eye blink, the eye blink. Again, move forward to the eye blink. This our eye blink. Usually, a normal eye will blink frequently. I don't know the number of frequent blink. I mean normal blink. You can check from the literature for the healthy eyes. But if our blink is more frequent than normal, means that maybe we have sleepy, yeah, a bit sleepy. Maybe maybe a bit how to say, a bit tired, yeah, something like that. So it's kind of this information telling us about this some informations, yeah. This this signal tell us about some information. And then how about the thermometer? Thermometer is, yeah, thermometer is not signal, because the thermometer is a device, the device to measure the body temperature. This is the device, not the signal. Okay, I hope it's clear. Okay, is there any questions? Okay, maybe move forward to the following system. The following is a system. System. What kind of system? Yeah, you can see here, smartphone is system. System. Why? What is the definition of system then? Okay, comparing to the resistor, resistor is a device. Yeah, device. Battery also device. Silicon, this is also device. Why the resistor, battery, and silicon is not the system? What we can identify from them? First is the system usually has a input and output. Input and output. So input, input, and this is out. This is out, and there is a block. We can say as a black box is a processing block. Processing block, let's say, is like processing the signal. Yeah, processing the signal. And this black box, we can say a system. Yeah, system. So system has an input and has an output. The input is signal, and the output also signal. Okay. This system proceed the input signal and uh, create or result the output signal, something like that. Okay. Okay. And then move forward to input signal of smartphone. Human voice. Yes, 100% correct here. And the screen image, why this is not input? Because the screen image is output. And speaker, this is also output. Display video, also the output of the smartphone, not input. Okay. Input signal of smartphone. Screen image. No, screen image is output. Displays video, speaker. Battery voltage. Yes. Yeah. That's the voltage of the battery will be used by smartphone to power up. Power up. When the voltage of the battery is decreasing, so not enough to power up the smartphone. Yes. Output signal of smartphone, recording video. This is input, of course. Battery voltage input. Smartphone temperature. Yes. By when we use a smartphone, particularly when used for computational intensive, for example, gaming or video streaming, the processor of the smartphone has a high computational complexity and running so high, so it's getting, how to say, getting increase the temperature. This is also indicate that the temperature that the smartphone maybe has a heavy load. Yeah, heavy load is kind of this temperature. Recording music is the activity for inputting the signal, not output. Okay. Okay, from this pretest, is there any comment or any questions regarding these questions? Please. Is there any questions? Hmm. No? No?
I think no, sir.
No. Okay, good. If no, let's move forward to the my presentations. Can you see my presentation?
Yes, sir.
Okay. Okay, let's start with the introductions. Actually, what is the signal? Formally defined as a function of one or more variables that convey information on the nature of a physical phenomenon. Okay, everybody got it? Let's explain more clearly about this. Okay, wait a moment. I will set for the writing mode. Wait. Oh, wait. I think it's no. Wait, wait moment, please. Okay, I hope right now I can write. Okay, good. Okay, what is signal? Formally defined as a function of one or more variables. Okay, if I write a signal as as this is a signal, is a function, so we can write mathematically become like this. Function one or more variable. Let's say as a variable t, maybe variable uh, uh, age, maybe, and so on. Or we can write being only one variable, depend on the one variable. So write like this. So a function, this function convey information on the nature of physical phenomenon. So this function brings the brings information. Okay, let's take a look. For example, this we conduct the experiment, something like this. The measuring the body temperature, yeah. This is body temperature. Y-axis, so in a Celsius degree, and this is, for example, time. Yeah, maybe you start from maybe you taking the measurement for your body temperature, let's say for 1 minute, 1 minute, 1 minute, and this is a 0 until 1 minute. Time is uh, minute, yeah. In the unit time is minute, and maybe this is. I hope you all already are healthy, yeah, in healthy condition. So 6:36.6, for example, yeah, and maybe you continual measurement, something like this. Okay, okay. This is tells us the the value of body temperature. So you can see here this graph, yeah, is kind of function, right? Function, yeah, function of T. This body temperature is a function of T because uh, the body temperature, yeah, Ft, and this is, for example, the T at the T0 might be T1, T2, T3. So it's kind of zero point 0.6, and this is kind of maybe still zero point 0.6, yeah. Maybe this is 2.68, maybe. Yeah, something like that. So you can see here, this is the signal, the value of the signal. This is the value of the signal. Yeah, the signal. And according to the definition, is a function of one or more variable. In this case, is function of one variable. What kind of variable? T. This variable is T. That convey information. Information. What kind of information? The information is that the body temperature is 36.6, means that the meaning of this value that you are all in healthy conditions. So on the nature of a physical phenomenon, yeah. What is the physical phenomenon? Yeah, this is the physical phenomenon. Physical, I means that like physics, yeah, physical phenomenon, not artificial, yeah. Nature is natural, yeah. Is yeah, natural condition, yeah. Nature, coming from the nature. Our body temperature is natural, not artificial. Okay. I hope you clear from these definitions. So let's move forward to the system. System is formally defined as entity that manipulates one or more signal to accomplish a function, thereby yielding a new signal. Okay, this entity, entity, you can see here, this is entity. In another word, as if I say, is a black box. Black box means that sometimes we don't know, we are not sure what inside of, yeah. Uh, but this system manipulates mean, how to say, this is the general term of processing, yeah. Processing, this is proceed the input signal, proceed, yeah, the input signal, or manipulate the input signal. Yeah, this input can be one or two, yeah, or more, yeah. Input signal, this like this. This is the input signal. Okay, to accomplish a function, there be uh, yielding new signal. Okay, to accomplish a function. So this system also function. Yeah, this is this system also function. For example, function depend on the one variable. Yeah. If the input signal has a tree, so let's say T1, true. Sorry, I mean this function is depend on the input signal, something like this. Input signal. If the input is 3, so we can write input 1, input 2, input 3, something like this. Yes. And then thereby yielding the new signal. We got the output signal. Impact after proceed, after manipulates this the input signal, we have the output signal, something like that. Yeah. Okay. From this first slide, is there any questions? Is there any questions? Okay, if no, let's move forward to the next. This kind of mass and spring, yeah. For example, you can identify here. You can identify that the mass and spring system, we can identify the input, for example, this one, the input, and the output is YT. The input is, for example, movement or like vibration, yeah, vibration up and down. And this input up and down, for example, here from the steady state and then going up and then going down. And this input signal will be proceed by the spring here and then generate the output. The output. The output is movement or vibration of the mass. Yeah, the black box here. Yeah, the how to say, the position or the oscillation, the signal output being like this, something like that. Okay, and given the input and the output, usually this information, input and output, will be used to identify, to characterize the system. Yeah. Yeah. Usually, why the system characterization is important? Because usually system in the real world is not clearly defined, and this system need to be, how to say, need to be analyzed or investigate to some purpose, maybe to optimize the output and so on and so on. And also the system that we can create, for example, the software, sorry, smartphone is a system. So we can create. So in the system, we can break down into subsystem, something like that. Okay. Okay. This is another example, relation between input and output signal. The mass spring system, and then water tank. Yeah. For example, the input is R0, R0, and uh, for example, we want to know the flow or debit. In bahasa Indonesia is debit, or in English is rate, flow rate. Yes, flow rate. Uh, and then given this reservoir, then how uh, a two-level reservoir. So, and then we can analyze the output of the second reservoir. Uh, and then, for example, another sample is telephone cellular system has input sound, and this is the output sound. This kind of application that, for example, you call your friend, maybe this is your phone, and this is your friend, maybe mom phone. You are talking to this phone, and then this signal is transmitted through the cellular network, and your voice will be out from your mom phone, and so that your mom can hear your voice. It's kind of input output system of cellular phone, or maybe in general a cellular network system, something like that. Okay. And then allow me to explain, maybe mention some system, yeah, in many real applications. For example, communication system, yeah. Communication system here, we can block using green block here. This is a communication system, consists of transmitter, channel, and receiver. The input is the message signal give to the system, and the output is the reconstructed, yeah, reconstructed of message signal, yeah. Mm-mm. And you can see here in the communication system is breakdown into several subsystem. You can see here the transmitter system, channel system, and receiver. The subsystem here also can be classified as a system as well, because they have an input, they has an input, and they has a output, as well as for the channel, as well as for the receiver. Yes. Okay. In the transmitter itself, also we can break down into maybe more subsystem. For example, modulation, yeah. To those already taken the telecommunication engineering or telecommunication system, I think uh, I think you already familiar with the modulation technique, yeah. The modulation is a system that conveying information into the carrier signal. So it's kind of putting information, signal information into carrier signal, something like that. Okay, is there any question? No. Another is about the sampling and quantizing and coding. This is a kind of analog to digital conversions. Also, we can call as a system. This is a kind of device in the communication system. Okay, let's move forward to the another system is a control system. Maybe some of you who are interested in the control system, you can see here. Uh, this is a control system. Hmm. Usually, the control system has an input or multiple input, and then this input will be proceed in the controller, and this controller will be feedback into the plan. Plan is the interested, how to say, is the object that we want to control actually, and then from the plan we will have the output, and usually this signal output, which is, for example, this is indicator for successful or unsuccessful control, and this output usually uh, uh, interference by the noise, or how to say, affected by the noise, yeah, and then this output will be used to make a correction, yeah, it's like a correct feedback from the output to adjust the input for the control, so it's kind of summations. It's like a closed loop feedback, yeah, because the output will be feed back into the input of the controller. It's like for correction, error corrections. Okay. As I mentioned before, that this closed loop will be can be categorized into SISO, single input, single output, or MIMO, multiple input and multiple output, and the variation of both, like a SIMO or MISO, something like that. So it's kind of the combinations between one and two. Yes. This kind of control system uh, has been widely applied in, yeah, shuttle space, yeah, because there is a lot of control, yeah, for the space shuttle or rocket or so on and so on. I believe that Elon Musk also apply this kind of control system. Yeah. Okay. Let's move forward to another application in terms of electromechanical system, like electronic system. In very special device, I mean, in very specific device, like yeah, this MEMS, micro electromechanical system, means that converting the vibration, yeah, vibrations into electrical pulse, so uh, we can get the some informations. This kind of MEMS technology is for gyro sensor, for accelerometer sensor, yeah, yeah, already embed in your smartphone. So that's why maybe when you uh, put your smartphone in the landscape direction or in the vertical directions, yeah, vertical or horizontal position, your smartphone will adjust the screen. So it's kind of electromechanical system function. Yes. Okay. This is the real image of microelectronical. Yeah, it's very actually the scale is very small. Yeah, very small. Yeah. uh, okay, another application is for remote sensing. Yeah, remote sensing is acquiring information on image from the object. Yeah, from long distance object using radar, using infrared sensor, using visible light sensor, using X-ray sensor, something like that. Yeah. Uh, uh, the input is, for example, for the radar, the input is how to say, the input is a reflection signal, a reflection of electromagnetic signal coming to the antenna, radar antenna, and then this reflection signal will be amplified so that we can get some information from that, and then display the position relative to the radar. Yes, infrared sensor, as well as also detecting the spectrum of the image. Yes, spectrum the image, and then will be captured by the camera, infrared camera, and from the this camera will be uh, display into the screen. Yeah, as well as for visible camera or X-ray sensor. Maybe the X-ray sensor we are familiar for medical imaging, particularly to see our organ inside of our body. Okay, this is kind of result from the remote sensing, capturing some image of mountain with the pattern of water, how to say, water flow. In the biomedical signal processing, also its work, particularly for nerve cell. We can see to our body that once we touching some goods or object using our finger, yes, and then this nerve means that our nerve cell is receiving the input signal, yeah, input signal, and this signal uh, is brought to the our brain or our backbone, yeah, to identify what kind of the object is, and then once we our brain proceed and then tells our maybe our eyes or even our finger again to make action, something like that. For example, our finger touching the some hit object, and then this signal will be proceed by our brain, and then our brain will take action to our eyes and our finger as well, maybe our eyes to look at the object, and then our finger try to avoid, something like that. Also, you can see this is the recording signal for the electrocardiogram or electroencephalogram is kind of our brain signal, yeah, or no, it's not our brain signal. Our, how to say, heartbeat, yeah, heartbeat signal is kind like this, up and down, and has a certain duration, yeah, it's like a wave, yes, something like this kind of a signal as well. Also kind of auditory system, how to design a room with a good au- audio system, yeah. For example, how to put the speaker properly, how many speaker should be placed in this room, for example. So the room can be enjoy for maybe for watching the movie or enjoying the music, recording music or a concert, and so on and so on. This kind of system as well. Okay. Okay. Let's move forward to the uh, differences between analog and digital signal processing. Yeah. Why we need to discuss this analog and digital signal processing? Because as you know that in general, based on the its behavior, uh, based on how easy how easy we can proceed this signal, so we can uh, distinguish into analog and digital. Yes, analog and digital. You can see here the digital signal has a more advantage than analog signal in terms of flexibility to proceed to make a processing, yeah, or in terms of repeatability, yes, repeatability. When we use a digital signal, we more easy to manipulate, to reconstruct, to how to say, to repeat, yeah, to repeat, I mean to reproduce, yeah, to reproduce the signal. Also, in terms of interference, the digital signal is more robust than analog signal. Why? Why? It is uh, interesting. You can see here. I will let you know some example. For example, the analog signal. What is the analog signal? Is our voice. Our voice. Yes, this is analog. And then, if we draw into a graph, yeah, we can write being like this. Yeah, being like this. Yes. And you can actually check using maybe a voice recorder in your phone. Yeah, maybe in computer. Yeah, actually our voice is like this. This is the magnitude. The y-axis is magnitude. Magnitude is how big the how big the energy, sometimes how big the power of the uh, our voice. And this is the x-axis. Usually this is time. Yeah, when you record your voice, actually will be display like this. So the gap, I mean the maximum and the minimum point reflect the power of your voice. Power of voice. Once the gap is larger, means that your voice is your power of your voice is high. Usually we can easily detect that you are speak louder. And then when the gap is smaller, means that you speak uh, uh, slower. Yeah, slower, something like this. Okay, this is the analog signal. Analog signal usually, but not always, usually continue in time. Yeah, you can see there is always a value in any time. Okay, and okay, this is the analog signal. And then for the digital signal, yeah, digital signal, usually digital signal is a by binary consists of two conditions, 0 and 1. 0 and 1. uh because 0 and 1, maybe we can write being condition. One is maybe 1 volt, but it is not always. This is just example. And then for the 0 is being 0 volt. Maybe some of you asking, is that always 0, sir? No, it's depend on the depend on the application. Sometimes some application, the definition is 0 is not 0 volt, but might be 0.1 volt. It is possible. So For example, so in this case we have 101. Nah, this is the digital signal. Uh, the digital signal. Okay. As I mentioned, that the digital signal is more flexible in terms of processing. Yeah, in terms of processing. Yeah, you can see because 101 is the condition is discrete. Yeah, so we can how to say we can amplify more easily. Amplify more easy. Yeah. For example, we want to amplify being 10 times. 10 times. So the signal 1 volt times 10, so it's being 10 volt. And then this 0.01 times 10 being 1. Yeah, being 1. So it's more easy to manipulate. Yes, compared to this one. Yeah, compared to this one, uh yeah, in terms of amplifier, maybe it has a similar degree of complexity. Yeah, something like this. Yeah, it is very might be similar. But for example, we if we put or if we add the noise we put noise, something like this. uh, Usually noise located in high frequency. So the signal I put here, for example, here, this is the original signal, and plus noise usually being like this. This is a small ripple in high frequency, being like this. Something like this. Okay. Okay, something like this. And this is the output signal due to the noise, affected by noise. Consider if the noise is so uh, I draw being like this, uh, something like this. Whoa. Wait. Hmm. Whoa, something like this. The noise is so high. So, uh, based on this signal, it is difficult to how to say uh, actually for example, this is time t and this is time t also. At this time t is time t, actually what is the nominal value of the signal? If the original signal might be this is 10, but after signal plus noise maybe not 10 but maybe 20, maybe 20. That's the effect of the signal. Okay. And then we want to reconstruct. We want to reconstruct. Actually, this kind of signal is very difficult to be reconstruct. Even for the if this is the audio signal, the output voice from the speaker is not so delicious, not so clear. Yes. Comparing to the digital signal, for example, this is plus noise. Plus noise. So this is plus noise. The output will become like this. So, from this kind of representative, you can see here when we define that where is the one condition. Actually, this condition we can more easily determine that this condition is still being one. Yeah, and This is also still 0. This is 1, even affected by noise. So by comparing two representative of signal, we can how to say, we can see that uh, the digital signal is more robust to the noise. Okay. In terms of reproducing the signal, this digital signal also more easy compared to this one, the analog signal. You can see here, by affecting by noise, it is very difficult to trace point by point in this kind of. So we can see that the digital signal more benefit than analog signal. Yes, that's why in our daily life we are very much uh, how to say, we are very much familiar with the system that proceed the digital signal compared to the analog signal. Even there is also many exist about the analog signal processing, something like that. Okay, is there any question? Differences between analog and digital signal?
Hello, sir. Excuse me,
Yes.
sir. I think I don't know if it's like relevant or not, but does the analog signal has any advantage over the digital, or the digital is just 100 times better, and like yeah, the analog is like all technology, or there is still some use case for analog signal?
Okay, very good questions. Uh, Actually, the analog signal. Wait a moment. Hmm, I'm trying to search the the application of analog signal that need the most of analog signal. Uh, mm, mm, as long as I know, yeah, as long as I know, until this time, the digital system, digital signal, or digital signal processing is 100% benefit than analog signal. That's my statement. I mean, uh, currently.
Okay, sir. So like right now, since most of us is digital, so digital is certainly much better. Yeah.
Yes, yes,
Okay. Thank you, sir.
yes. You're welcome. Is there any uh, is there any question? No. Okay, if now we move forward to the classification of the signal. Classification signal, yeah, we can classify into different term, yeah, into many type of term. First is classif we can classify based on the continuity, yeah. For based on the continuity, there is a continuous signal and discrete signal. Actually, from this name, we can easily understand the continuous signal. Oh, at the moment. Continuous signal we have to define the signal in certain domain. Usually the domain is representing at the x-axis. X-axis, we can take an example. For example, t domain means the time domain. In domain, what is the signal in time domain is like when we recording our voice is the signal in time domain. Okay, and then when you recording the signal, there is the graph that continue. There is no breaking point. There is this line or this graph is continue. Means that no breaking point. So uh, there is always a value anytime. Yeah. So in any time means that uh, in any point here, there is always a value. There is always a value here. Maybe, for example, you recording from maybe for 1 minute. For 1 minute, yeah, recording for 1 minute. Uh, for 1 minute. Uh, from 0 second into 60 second. When we pick up a value at the maybe at t equal to 15 second, there is always a value. Okay. Even with t equal to 15.001, there is a value. There is a value, or there has a value. Okay. Please keep it on mind. Yeah. This continue, the definition of continue. And mathematically, usually, if the signal is x in domain t, we can write thing like this. Use uh, uh, usually in t, small t, yeah, small t, and this is in bracket, yeah, in bracket, yeah, in bracket, something like that, in bracket, in bracket. And for the discrete, I will use a different color, maybe using this one. Discrete means that uh, uh, this is a 0, this is This is maybe still time. Yes. The discrete is a result of sampling. Yeah, result of sampling. For example, we only record every 10 second. 10 second. For example, here, maybe I will use a blue color. Okay, blue color. Okay, this one this is 10 second. This is a 20 second here. So this one 30 second, 40, say 50, and this 70. Okay, okay, okay. This you can see here. This is the result of discrete. Comparing to the continuous signal, you can see the value of the blue, yeah, is not always exist in any time, but only in certain time. Means that at t equal to 0, t equal to 10, t equal to 20, t equal to 30, t equal to 40, and t equal to 50 and 60. Okay, so how about at t equal to 5 second? There is no value. No value. Okay, there is no value here. No value. So this is the meaning of discrete. So mathematically, we can write being like this, square bracket, and this notation being n, something like this. Is that clear? Okay, something like this. Xn, n mean then representing this one, n1, n2, n3, n4, and 6, and 5, and yeah, something. This is in term of n, yeah, and something like this. This is bracket. This is in bracket, yeah. Maybe parenthesis, maybe in English, yeah. I hope you have a clear explanation. Okay. Still very easy about this one, I hope. Something like this. This one. This is the continue xt, and after taking a sampling with a certain period, we got this representative of signal. And then how the relation between continuous and discrete signal, this one. For example, this is the continuous signal. So expression of continuous signal is xt, and then this continuous signal is sample, is sample, sample is sample, is sample, sample with t sampling time, t sample. T sample means that a certain duration that the signal is taken. Yeah. For example, every 10 second, yeah, let's say this is a 0, and this is maybe this is 10 second, this is 20 second, this is a 30 second, this is 40 seconds. So in this case, we pick up this value, this point, this point, this point, and this point. Okay. Okay. So from this and for the blue one, we can write the discrete signal being n xn, right? And the relation between continuous signal and discrete signal become x t times n. This is the time sampling here, put in here, something like this. So that's become a discrete signal. Okay. Is there any question? If you have any question, please raise your hand or not or by give me your voice. Another classification of the signal is even and odd signal. Even and odd signal. You can see here. mm, Even and odd signal. Yeah. Even signal means that you can see here from mathematical expression even signal. So, for example, we draw like this. Even signal means that this is a positive region and this is the negative region. Mean T become positive, this is T become negative. This is xt. So 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 in this case, you can see here the magnitude of xt is the positive region and the negative region is similar. Means that you can see similar. This is x minus t and this is x positive t and similar. Yeah, similar. Similar means that similar. So this signal we can as a even signal. What for example, that signal that similar with this characteristic is cosinus signal. Cosinus signal. You can see here in the positive region and the negative region has the same value. Okay, same value. Okay, and okay, move forward to the odd signal. To the odd signal means that you can see here the x minus t is negative of xt. So I will draw using red color xt. For example, the xt is minus. So for example, the xt is positive, something like this, and the x positive xt, x for positive t is negative. So being like this. Opposite, yeah, opposite value. This is negative, this is positive. Okay, it's clear. And then for this kind of odd signal, it's a sinus. You remember that? Oh no. Sinus is not like this. Okay, it's like this, right? This is a odd signal. You can see in this for xt here, this is x minus t. And for the x minus t is always negative and this is positive. So it's opposite, yeah, opposite. So it's fulfill this characteristic of odd signal. Okay. Uh, that's about that's all about the even and odd signal. Okay. Okay. And then periodic and non-periodic signal. Uh, this is also important. Hmm. Periodic means that the signal is repeat in a certain period of time, and non-periodic means that the signal is always changing in time. Non-periodic. That's all. This kind of periodic signal you can see here in every zero point 0.2 second the signal is repeats, yeah, into the beginning. And non-periodic means that maybe only exists in certain time and there is no axis in another time. Also, this is non-periodic. Yes. Okay, and then we've moved forward to the randomness. Based on the randomness of the signal, you can see we can classify into deterministic and random signal. Yeah, deterministic means that we can determine the value of the signal anytime. Anytime. So, for example, sinus or cosinus. Yeah. Uh, sin maybe uh, sin 2pt. Uh, we can draw thing like this. This is 140 means that one fulfill one cycle. So this is kind of deterministic signal. You can see here, as I mentioned, that deterministic signal uh, can be determined anytime, even in the past or in the future. So we always can determine the value. For example, here, sin 2pt, we can determine even the t might be minus 100 years or 100 years ago. We can still can determine the value of the Zenus. Or maybe 1,000 years ahead, we can still determine this signal. So this the meaning of deterministic signal. How about the noise or random? Oh, no. I mean, yeah, random signal. Random signal is kind of noise, and the occurrence we cannot predict. We can compute. We cannot compute. So we cannot predict any time, any. Yeah, we cannot predict any time. Okay. Is there any question comparing the deterministic and random signal? Actually, the random signal, as I mentioned, is kind of noise. Noise is random signal. Yes. Okay. Any questions? Okay. If no, let's move forward to the another parameter. This is not signal classification, but it's kind of uh, characteristic of the signal. The signal has energy and has a power. Difference between the energy and the power is respect to the time. We can define the energy when it's independent of time. So it's not belong to the time. But if the energy for certain time, the energy for the certain time, capacity or amount of energy in certain time, we say as a power of the signal. Okay, so you can see here the energy when the t is unlimited. You can see here something like the integral from the minus infinity to the positive infinity, x2 square t. But for the power it should be average along the duration of the signal. That's the power of the signal, something like that. Okay, that's all the presentations. Yes, for the first week, but uh, please be patient that surely you have activity. You can see here. You can see here. Uh, this is a group activity that you have to conduct it right now. Right now. Please conduct this group activity, and then you have maybe 30 minutes to complete this activity. And I will break you into two rooms, yeah, two room randomly, and then please conduct this what this activity. I will send you the activity. Wait a moment. I think this one is okay. I will send you to the this one. Signal and system. Okay. And then I will break you into two rooms for group activity. After that, you can explain uh, one by one.